So welcome everybody. Thanks for coming to the second day of the Dual Use Marine Technologies workshop. Yesterday we had a good, an interesting discussion from the two keynotes plus several other speakers. Just to give a quick summary, set the stage for today, and maybe some of you missed yesterday. We saw some good examples from Ireland about how they've built upon their competitive advantages and developed their marine sector quite a lot over the last several years. And there are some similarities in Cyprus, and we identified actually during the discussion session some sectors where Cyprus has a competitive advantage, which we already know that, but it was good to hear it's important to build on those and to track their progress with an economic analysis over the years, and then try to focus on small scale projects and link with other countries and regions for larger scale projects. Some of those areas were shipping, tourism, and offshore or aquaculture in general. So today we're going to talk a little bit more about what's happening in Cyprus in terms of research projects and marine observing. I will hand the floor over now to the moderator for the first session, which is my colleague Gerald Radica. So Gerald, if you'd like to introduce the next speakers, and if there's any housekeeping that people should know about, that would be a good time as well.
Thanks, Dan, and good morning, everyone. Welcome to day 2 of the Dual Use Marine Technologies workshop. Ehsan Abdi is the head engineer of Cyprus Subsea. He just signed in. He'll be talking about the Smart Standardized Marine Sensor Cable Interface and the Smart Cable project.
So, good morning, everyone. My name is Ehsan Abdi. I'm an engineer with Cyprus Subsea. Today I'm going to present a project we've been working on for the past couple of years. It's called the Smart Cable. So let's look at the problem we're trying to tackle here. As most of this audience would know, there are plenty of sensors being deployed in our world's ocean, but although not nearly enough. So this is a map of Argo floats. So this is not considering all the gliders, buoys, ship sensors, moorings, and everything else that is being deployed. But in fact, they are just a fraction of our oceans. They're monitoring a fraction of our oceans, and what we need is looks a little bit more like something like this, where we have an interconnected ocean measuring everything, for example, down the food chain, everything from chemical molecules and nutrients up to planktons and fishes and marine mammals. So everything interconnected to each other. But in order to achieve this, we need a ton of new sensors. And we need these sensors to be efficient both in terms of cost, so the deployment cost, the integration and deployment cost, so easily integratable and deployable, but also we need them to be sorry about that. Okay, yeah, so we need them to also be efficient in terms of their data. So what that means is that their data needs to be accessible to as many scientists and users and stakeholders as possible, and as reusable and as easily reusable and interoperable as possible. So we need standardization. Standardization. Let me actually move you guys up here. Okay, maybe it's better now. So standardization has many different parts, or it affects a lot of different things. So for example, standardization helps the deployment, easier deployment. So the idea is to have sensors similar to when we have USB devices, where we can just plug in a USB device and it just works. So the same thing for the sensors. We need them to be plug and work to reduce the integration time. This will also help with the operation. So standardization will also help with operation. So operating a fleet of, for example, different type of sensors and platforms. And also with the access to users and stakeholders. So different people can access the same data visualized, or if they need to run it into their models. So standardization will help with all these three factors. So what we have here is that, okay, so we need to tackle this problem from the hardware layer, because by the time that we get to the data layer, it's a bit too late. Every institute has their own way of analyzing data, running QC control, and the data that comes at the other end is just totally different. So if we need to tackle standardization, we believe that we should actually start from the hardware layer. In the hardware layer, we have sensors and platforms. On one side, sensor, and on the other side, platforms. The sensor and platform manufacturers are reluctant to actually apply any of these, any standards, unless it's part of the regulation, unless they really have to, because it's engineering time for them, and they benefit from it. They have a competitive advantage, maybe, to actually have different types of data coming out the other end, so that they can sell their services, visualization services and stuff like this. So, but they all have one thing in common, at least in the marine area. They all have a cable assembly in common. So usually there are two sides of the cable, a pigtail called, and they come together over molded. It's a service that many companies do. You over mold the cable, and you have a cable assembly connecting these sensors and assemblies. So we thought actually we tackle standardization from this point. If we can standardize this point, then it's yeah, our job is going to be much easier. So what we did is that instead of just having a simple cable in there, we have a circuit board over molded inside the cable. So that's where we come with the idea of the smart cable. So smart cable is the aim of the smart cable is to take care of all the integration tasks that a normal engineer would do, such as a voltage regulation, for example. Voltages could be different levels of the sensors and the platform. Protocol translation, they might speak different languages, basically. Processing, so now you can get really powerful processors for sense. So if you have a processor in there, we can actually take time and effort away from the main platform processor, which has the valuable job of actually directing the whole mission. So we can analyze this data on the cable and just output some snippets. And also sometimes we might need, for example, storage to store the data, again, for the same reason, to free up time of the main processor, basically. So we came up with this modular design of the board, where we have protocol modules on each side, processing modules, and power and miscellaneous modules. Sometimes, for example, you need a really accurate clock for some sensors. Sometimes the sensors are analog, you need to convert them to digital. So we came up with this design, and at the end of the project, the whole thing will be accessible online, fully open source, both hardware and software. So let's look at an example of what this cable could be used for. We have in this case, we have a glider monitoring marine mammals. So right now there's a hydrophone going on top of a glider, and they just passively record any sound that they hear in the ocean for as long as they can, for as long as the power budget allows. And then when they are recovered, scientists would look at this data, hours and hours of data, and try to just find these clicks or any interesting sound that they look for. So what we can do is that, so we take these hydrophone elements, it usually transmits its raw data in Ethernet or USB protocol. We take that raw data but we have to first of all analyze it and then bring it to a lower bit rate to send through the satellite back to shore. So we, for example, put a memory module for saving these raw snippets, and a processing module to actually process this information that is coming, the acoustic stream, and detect the event. And we can actually output on the other side just the text file of the events that the glider detected during the last dive. For example, so many humpback, it heard so many humpbacks, and we can send it back through satellite back to shore. Another example, so going back to the standardization, is the OGC POC protocol. So the OGC is the Open Geospatial Consortium, consists of over 500 companies around the world working in the geospatial standards. So they come up with this set of standards for integrating, for creating a sensor web, basically. And in the hardware layer, this standard, one of these standards is called the POC protocol. The POC protocol, basically what it does, so the sensor is defined using a file. It's called the sensor descriptor file, or sensor ML. Uses XML to define this sensor. So everything about the sensor, any metadata that you might need about the sensor, you might need to know, for example, calibration date, manufacturing date, serial number, and all of this. And it stores that on the memory of the sensors, or in this case, the memory of the cable of the sensor. And once the cable is plugged in to a PC or to a platform, it uses the POC protocol to retrieve this sensor descriptor, and then it can be integrated. Basically, out comes the other side, a visualization, for example, or data can be saved in a database in a standardized format. So we can easily integrate that into our smart cable, and we did just that in Canary Islands a few years ago in Plocan Institute. We used a couple of smart cables. So on the right side, you can see a wave glider, which is a surface vehicle. It integrates a couple of optical sensors. These are actually analog sensors, where if you would need to integrate them in the traditional way, it would take a few weeks or maybe months even. And you just plug in the sensors, physically integrate them, take a day or two maybe, and out comes the other side, a visualization on a standardized service using this sensor web enablement idea. So these are two of the examples of what we've used the smart cable for. There are many more examples. We've been using the smart cable to integrate sensors, many different types of sensors into our gliders. So with that, I think I am done. So thank you everyone for your time. And is there any questions?
Thanks, Ehsan. I actually had a question. You'd mentioned platform manufacturers are hesitant to standardize the data output format. So you're talking about engineering time for integration. Do you have like a ballpark figure for how much time would be saved by using the smart cable as opposed to like a manufacturer doing this on their own?
It really depends on the integration. It really differs
Sure.
from time to time. For example, the acoustic example is many months of engineering effort, but some other integration tasks might take weeks.
Mm-hmm.
So the fact is that for every let's say integration, you would need a new board to be made. So in this case, we actually make this new board into a standardized board where we use modules. So for any type of integration, you can just use a different set of modules and easily achieve that goal.
Cool. We also have a comment from Nikitas. There's something similar for undersea power cables, connection to offshore renewable energies.
The same idea, okay, so the same idea can be used everywhere, actually. So it doesn't have to be anything just specific to a sensor and a glider, let's say, integration. So the smart cable idea can be used in any even land sensors or offshore cables. Yes, we have to look at the problem, and we can for sure tackle it if the smart cable is applicable there.
Another question from Andreas. Will it be able to work under extreme temperatures, for example, the Arctic Ocean?
Oh yes, so actually the Arctic Ocean is very easy to work with. I mean, especially because it's most of the time underwater, so which is warmer. But the components selected for the smart cable are quite, let's say, hard components that you use also in space. So yeah, the main problem is not the temperature. The main problem is the pressure. So we actually have to work really hard to find the molding, the resin material for molding that would withstand the pressures of 6,000 meter
for sure.
water. So yeah, definitely can work in the Arctic.
Another question from George. Very interesting product. Is it compatible with other communication protocols and data formats? And I think you kind of explained that, but if you can go into further detail, Ehsan, that'd be great.
Yeah, if you can specify which protocols you're referring to. So I think we've tackled all the protocols that are our usual marine sensors are contain. So such as I think I mentioned CAN, RS-232, 422, and Ethernet, USB. So yeah, we can add, actually, if there is a protocol that we haven't integrated already, we can actually make that module, and that module then easily can go on top of this product and can work with the rest of the system. Yes.
Thank
Awesome.
you. Thank you very much.
No problem.
I guess another Nikitas is asking about if you know of any cases of power cables
Sorry?
that's similar to the smart cable.
Power cables.
Yeah, it's in the Q&A.
Like subsea power or power cables.
Yeah, just sorry that I'm intervening. I'm from Greece again, Professor Nikitakos, because we are doing a project connecting offshore renewables with some other places. And I'm wondering if there is any use case or any best practice of power cables having this, integrated these sensors on that. Just I'm asking from curiosity if you have in your mind something.
Sure. So if there is actually data going on top of that power cable, then it makes sense that we use.
No, I'm asking in practice if you have some case.
No, we haven't faced anything.
Okay,
no.
okay.
Yeah.
This is my question. If you have in
practice. Okay. No. We have actually haven't worked with the offshore power.
Okay. Thank you.
Okay.
This is Dan. Hi. You might want to mention a little bit about the power consumption, because I think that's something that is unique about that.
Yeah, that's right. Yeah. So what I forgot to mention is that it's very low power consumption. So, and it has this sleep mode with micro watts of power usage. So yeah, so that was so what I was referring to, where I said it actually takes the effort away from the main processor, is because it's so efficient in terms of power, that if any processes can be done on the smart cable, because it's so efficient in terms of power, it can save a lot of power down the line. So yeah, it's a very efficient system.
Awesome. Thanks, Ehsan, for your presentation and for answering these questions. Any last words, or you good?
I think I'm good. If there's no more
Great.
questions.
And we'll definitely include links to like the data sheet, as well as other information about the smart cable in our follow-up email to all the attendees of this webinar. So look out for that. So thanks again, Ehsan.
Sure. No problem.
We're now going to transition to, as I was introducing earlier, so next we have Dr. Luis Hadjioannou, the director of Enalia Physis Environmental Research Center, and he's also an associate researcher at CMMI. So his talk is titled Disturbances in the Marine Environment of Cyprus in Search of Solutions. So take it away, Luis.
Thank you so much, Gerard. Perfect, thank you. All right, so as Gerald said, well, or maybe he didn't, I missed his introduction. I'm a biologist, marine ecologist, and I'm working as a director of Enalia Physis, and I'm also affiliated with the CMMI, and what I'm going to present to you now is some examples of projects that I've been working on and subjects that we will be working on at the CMMI as well, through some projects that I've been participating in. I have to be honest, I had difficulty in choosing which subjects to discuss given the limitation in time. There's so many different issues with the marine environment, so many disturbances. Just to jump in, and I assume that most of you know these things, but let me just give a brief introduction about the marine environment in Cyprus. It does include a lot of important habitats such as Posidonia meadows, reefs, submerged caves, etc., and as well as some important but also vulnerable species such as turtles, monk seals, rasmobranchs, cetaceans, seabirds, and even though it's been considered to have a lower species richness than the west side of the Mediterranean, not just Cyprus, but the Levantine in general, it's also possible that is because of less intensive sampling effort as well. So less research has been done in our waters. But in any case, it's also a hotspot of Lesepsian migration. That's species migrating through the Suez Channel and becoming many times invasive. So all in all, there is a lot of interest in the marine biodiversity of Cyprus, but also a lot of disturbance. Okay, I don't think I need to go through this slide in detail, but of course there is a lot of benefit from the marine environment through seafood, tourism, shipping industry, offshore drilling. Of course, some of these are benefits, but could also be potentially problems. Then with respect to disturbances, there's a long list, but here I put some of the most important ones. Of course, climate change with increasing temperatures and severe storms intensified in the last few years and forecasted to be more intensified. And you can see how big of a problem it could be. The fisheries are having problems through bycatch or overexploitation, invasive species, we mentioned those, pollution, eutrophication, marine litter, plastic, coastal development, of course, and noise. But I will jump now into the subjects. The first subject is with regards to fisheries, and I'm going to describe one of the projects that I've been working on, called Understanding Multi-Taxa Bycatch of Vulnerable Species and Testing Mitigation. This is a project that is funded by a private foundation, MAVA, and there are partners apart from Enalia, Spots, BirdLife International, University of Exeter, and BirdLife Cyprus. And the phase one of the project was, the duration of it was from 2018 to 2020. We got a lot of results that I will describe briefly. And now we just started phase two. What is the problem? For those that don't know what is a bycatch, is the unintentional catch of discards and of discards and vulnerable species. So basically, fishermen use some tools to catch some species. They target some species, but unfortunately, they catch other species as well, which are not targeted. So it's a very important threat. And the vulnerable species that I'm referring to are sea turtles, cetaceans, seals, so the mammals, seabirds, and elasmobranchs, such sharks and rays. So this is considered to be a key conservation issue in the Mediterranean. And the initial aims of the project, which we've already developed, first of all, was to develop and train teams of onboard observers and have them going on board with fishermen to record the bycatch. We also trained fishermen to complete logbooks by self-reporting. Of course, this is not so much reliable, but still is one way of getting data. Another aim of the project was to build trust, of course, between the bycatch experts and the fishing industry, and to implement taxon-specific studies so that we can identify the important areas for these vulnerable species and understand the bycatch problem at fine spatial scales. Further aims included raise awareness, of course, strengthen fisheries management, and develop capacity through NGOs, research centers, and government institutions to tackle this problem. Quickly to show some of the results through just the onboard observations. During the 2-year period, we've identified lots of species that are being bycaught, mostly elasmobranchs and rays, but also cetaceans. As well as some indication of bycatch of seabirds. Many of these are vulnerable. Some of them are critically endangered. And just to show you what we've very broadly identified, this is just an example of one area, the Larnaca Bay. It's an area that is of high interest to us. And we've identified which species are being bycaught, but very generally. So what next? Through phase two, we are already testing some mitigation tools, such as LED lights that are being put on fishing nets to help deter sea turtles, some circle hooks, and this kind of technology used to avoid the bycatch of sharks and rays. However, I'm sure that there are better and more innovative and technological solutions. First of all, to try and monitor fishing vessels, for example, through the VTS technology that was already described in previous sessions, or even with the use of hydrophones, echo sounders, etc., to be able to identify the important areas in better quality. And also, of course, perhaps there are others which I'm not aware of. Moving on to the second subject with respect to invasive species. As I mentioned before, Cyprus is a hotspot of Lesepsian migration. This is where most species coming from the Suez Channel invading the Mediterranean touch first EU grounds, let's say, and we are already packed with lots of alien and invasive species. I'm going to just present one of the projects that works with invasive species, and this is Lionfish projects. is a EU-funded LIFE project, and it aims to build an early response and targeted removal of lionfish to prevent an invasion in the Mediterranean. Partners include the University of Cyprus, Enalia, MER, Department of Fisheries, and the University of Plymouth. Just some general facts about the lionfish. It's known to inhabit shallow waters, but also deeper waters from 0 to 300 meters. It's a relatively long-lived species. It has sharp venomous spines. It consumes a lot of prey on a daily basis. It's a very generalist predator, as we have found out through some biological analysis we did. It can grow up to 43 centimeters. It sexually matures very early, in less than a year, and it can reproduce and lay a lot of millions of eggs per year. It was first recorded in the Mediterranean in 1992, though that was just one record. And then there was a huge gap, a big silence for about 2 decades, until it was recorded again in Lebanon in 2012. And since then, it has been found in Cyprus. Sorry, that's a mistake. Since 2012, it has also been found in Cyprus, and it has been expanding significantly, but not just in Cyprus, but also in the Mediterranean. This is a bit of an outdated map, but as you can see, by 2015, 2016, the lionfish had already reached the coast of central Mediterranean. And now 2020, it still hasn't expanded further to the west, but the South Aegean is full of them. The south coast of Turkey is full of them. And they're not just expanding, but they're multiplying in numbers. So the densities are also increasing. Through some monitoring sightings that we have done through the Realignment project, but also through other projects, we have found that, as I said, the lionfish numbers are increasing in density, especially in particular areas such as the eastern side of the island. It is a threat to biodiversity. We know that it impacts species, important species and ecosystem engineers. It does act synergistically with other stressors, for example, with increased temperatures. They indirectly assist with the increase of algal growth. They compete with native predators and can cause significant reductions in native species as well as in commercially important species. So there is also a socioeconomic impact from this invasion. It also assists in the degradation of important habitats, and is also a public health through the venomous spines that could potentially deter diving tourism and bathers, but this is debatable. In any case, what has been done until now through Realignment and other projects, we've developed the capacity and the mechanisms to tackle the invasion in shallow areas. We've assessed the risks, increased awareness, created the surveillance and early detection system for shallow areas through citizen science. We've developed removal action teams. Again, this is for shallow areas, explored potential small local market niches. We've promoted it as much as possible for consumption because it is edible and quite tasty as well. And we've also developed tools for managers and tried to transfer the knowledge to neighboring countries. However, all these things have been done for the shallow part. We know that the lionfish, or we have serious indications that the lionfish can be found in much deeper depths, and that they have also large densities in the depth. So What if we tackle them in the shallow? It doesn't do anything, since as soon as you remove them from the shallow, they move back and reoccupy those areas. They come from the deep and reoccupy these areas. So there is a need for innovative and technological solutions. And some of these solutions have been tested and or are still being tested in other areas where the lionfish has invaded, such as the Western Atlantic, where the lionfish has been there for the last 25 years. But still, we need to try and use these innovations, or even do some of our own, to see and first of all, identify the problem in deeper habitats through remote sensing, most probably, but also to develop the capacity and mechanisms to tackle the invasion in deeper habitats. And here I added two pictures from examples of technology being used in the Western Atlantic. On the left, there is the RSE robot. This is an ROV that uses electricity to stun lionfish in the deep and then hoover them inside. And then also there are artificial reefs, traps like the one on the right. As I said, these problems and these solutions are just for the lionfish, but the lionfish is not the only invasive species that causes serious problems in the Mediterranean. This, and in Cyprus in particular, this is just an example. And then thirdly, the third subject that I'd like to talk about is with regards to marine protected areas. And when I talk about marine protected areas, I mean natural protected areas, but also man-made or through artificial reefs, the use of artificial reefs protected areas. And we do have them in Cyprus. I'm going to use the example of Kakoskali, marine protected area. This is an area in the west of Cyprus. Sorry about that. In the Agamas area. And this is an area on which we've been doing research for almost a decade now, and we've identified it as very important. But also we had a project that finished a couple of years ago and finished very successfully, where we got funding from MedPan. This is the Mediterranean Protected Areas Network, supported by MAVA and the Prince Albert of Monaco Foundation, to try and enhance participation from stakeholders in this protected area. And through this project, we managed to liaise with stakeholders such as fishermen and the Department of Fisheries to identify the zonation, and finally managed to designate it, not us, the government, of course, to designate it as a marine protected area. Why is this area important? Well, it does have a high ichthyofaunal diversity and abundance, and this we've identified it through visual census techniques, through scuba diving. Just an example of a few of the important habitats, I mentioned them earlier. This is an area that includes Posidonia Oceanica meadows, submerged cave, reefs, and other sandy and muddy expanses. And in the cave, just to give an example of how important this is, we've identified 2 new species for the Levantine, and these are on the top right. These small fishes that haven't been recorded earlier in Cyprus. A few words about Posidonia Oceanica. These are a priority habitat included in Annex 1 of the Habitat Directive of the European Union, is known to support high biodiversity. It forms a natural barrier, thus providing protection for the coast from erosion. It does produce a lot of the oxygen that we breathe, but it also supports many organisms by providing protection, foraging grounds, and reproductive grounds. The second habitat that is found in this area where this Kakoskali Island area is found is a very unique submerged cave. Again, this is a priority habitat included in the Habitats Directive of the EU. It has unique biostalactites that are created by a complex of organisms, including corals, bryozoans, sponges, bivalves, etc. It's so unique that we only know about research in this kind of caves done in a couple of caves around the world. So it's very important to continue monitoring and protecting, of course. And the third habitat that is found in the Caccoscali area are reefs. Again, a priority habitat. Just in front of the island, the cave, and the Posidonia meadows, there is this 20-meter wall that enjoys high biodiversity of ichthyofauna, but also has biogenic coralligerous concretions and many other organisms. And the importance of this area is not so much on the independent habitats that are found there, but on the close proximity that they are found. As I said, the cave system is very close to the Posidonia Oceanica meadows, which is also very close to the reefs and the coralligenous habitats. So this nutrient pathway and connectivity between the ecosystems at Caccoscali Islet is unique. This was the result of our efforts, and of course efforts joined by the DFMR, the Department of Fisheries, which pushed forward the designation of the protected area. As you can see, the pink area is a no-take zone, so no fishing is allowed, and in the green area, only from professional fishermen fishing is allowed. Still, the area was managed to be protected, but threats are also found there through illegal fishing, through ghost nets from previous years, through the scuba diving contact, accidental contact most of the times, through anchoring, through again the existence of non-indigenous invasive species, rising temperature, marine pollution, etc. And so what are the next steps? A management plan would be nice to be created in this particular area, but also not just for the Caccoscali area, but also for all the other marine protected areas of Cyprus. And so there is a need for innovative technological solutions, and in particular, a remote surveillance system would be important to be installed. There is a very nice example of marine protected area in the Cyclades. Yaros MPA is called. It's also an island, a much larger island than Caccoscali. But they have managed through the years to build a really, really good remote surveillance system. You can see some photos on the bottom of the slide. They are using maritime radar, infrared cameras, and all sorts of other power and communication infrastructure, including a vessel traffic service to monitor vessels activity. And that is something that we would like to be able to use in the marine protected areas in Cyprus, Caccoscali and the rest, Cape Grego, etc., to be able to minimize illegal activities, but also use other technological advances for monitoring of marine biota, such as ichthyofauna, perhaps with permanent cameras or other equipment, and also to be able to record physical-chemical parameters remotely so that we can minimize effort. And with this slide, I would like to end this presentation and thank you very much for listening. Thank you to the organizers as well for inviting me to give this talk.
Thank you, Luis. It was a great talk. And you actually do have a question from Elias. He's asking, how are the lionfish detected? What kind of sensors are used or appropriate?
For the moment, as I said, we're using mostly citizen science. So if you can think that there is thousands of divers, recreational divers, visiting areas in Cyprus every day. Well, maybe not every day, but in the summer season for sure. We get information from them, and we have built an application where they can send their records there. It's called MEDMIS, Mediterranean Marine Invasive System, and is run by IUCN.
There's also a comment from Andreas. One suggestion is to create an app, or yeah, I think you're talking about this, or actually to create an application smartphone, including pictures for protected species, banning fishing areas, and useful information by targeting mostly young people to achieve a positive influence in the long term.
Indeed.
Any thoughts on that?
These are things that are already running, but of course, enhancing them is the goal.
Definitely. I did notice on, in terms of the Red Lion Med Life project, there was a photo exhibition in different cities around Cyprus. Can you speak to more about that? I know it was on social media and all your websites, but
yes,
maybe people aren't aware.
Yeah, I mean, there's a lot of actions that were run through Reliant Med, but also through other Lionfish projects. And one of them was that one. I didn't talk about all of them because I would need half an hour talk just to talk about Reliant Med. But yes, indeed, we did have a dissemination activity running the last month, I think, in different cities. With it was basically a photo exhibition of lionfish.
Earlier during your presentation, you had mentioned building trust between the experts and fishermen. And yesterday we had a discussion about OS Aqua and the need for more collaboration. So can you give an example of how you were able to build that trust, or what kind of activities or events, or just like what you ended up doing to really make these connections with the local fishermen?
Yeah, to be honest, I think the most important thing to be able to build relationships with the fishermen is time and a lot of effort. These things rely a lot on interpersonal relations. This is the nature of the fishermen's behavior. Let's say they do like for people to invest time in them and spend time with them, either on their boat or at the coffee shop with them. Discussing about not just fishing, but in general. They are this kind of people that really want to build relations with you in order to build trust and accept you even on their vessels. If you consider that their vessels are places where they spend a lot of their time, so it's their home. So by them allowing you to go in their vessel means like they're accepting you, they're welcoming you to their home. So it is very important not to approach them in a strict professional way. You have to approach them in a more personal way.
Yeah, that's actually kind of in line with what Dr. Paul Brewster was talking about yesterday, and how people may be siloed in their different departments. But the point was when actually two departments maybe, or two organizations are close to each other and they're able to meet in a more informal setting, like a coffee shop, that they were able to actually have synergies with their projects and within their departments. Another comment or a question from Olia. Our house convention actually pushed forward the public participation, and there are actually ways to engage stakeholders. Okay, thank you for that. Are you familiar, Luis, about this?
No.
The Our House convention?
Our house.
Yeah, maybe I'm pronouncing that incorrectly.
It's a Danish city.
Okay.
I don't know how you say it.
Aarhus.
Okay, no, I'm not aware of it. Sorry, but please, if you can provide some information, a link or something, then I would be very interested in looking at it.
Luis, I have a question, if you may.
Of course.
about the fishermen. The past year, fishing has been interrupted through the COVID pandemic. With your interaction with the fishermen, have you heard them say, either complain about things, or if they've noticed an increase in fish, and if you're aware of any studies that are currently running to see whether things have changed in the natural environment? We know from Greece that some species were already recovering 6 months into the pandemic.
Yeah, that's very interesting, Rana. Thank you. Well, first of all, just to say that, of course, fishermen were affected by the COVID pandemic. But to be honest, fishermen are also affected by so many other things, either related to climate change or also politically, because many of them in the past couple of years were not able to go out fishing, especially the polyvalent fleet, either due to the overgraze or whatever or whatever vessel our neighbors have been using in search of oil and gas, well, many times illegally. So they have been affected by restriction from fishing in many areas. But with respect to your second question, I mean, we're in the process of collecting data this year, but it's still being interrupted by either COVID or other issues. So it's very difficult to come to conclusions as to whether the environment or some of the fishing stock has rebounded. Perhaps the DFMR would have more information about that, since they are running monitoring projects with the fishermen more regularly. We are mostly focused in this project on specific species, vulnerable species, even though we do collect information also with regards to other species. But the collection of information has ended in phase 1, and it ended right before COVID started. So the phase 2 of this project is mostly to find mitigation tools.
Good for the project
Yeah.
that it ended when it ended. I have one more question regarding the Kakoskali.
Yep.
You mentioned a new species. Are these new species to science or new species to the area? And if yes, where are they from? You also mentioned a monitoring program. Do you regularly go there and observe, or have something specific?
Yeah, the two species that I mentioned are the ones you can see here in the top right. These are really small fishes, and they are speleophilic species. They were first identified for Cyprus. They were new species for Cyprus, and I think for the Levantine even. The further west they were found was in Greece. And the monitoring, we are doing it regularly, but not as systematically as we would like, due to up to now lack of funds or a lack of a project that would allow us to do it more systematically. We are looking for ways to do it more systematically, but also for ways to do it more efficiently, as I described, perhaps with the use of technological advances.
Thank you. Through OS Aqua, we are looking at, because if you're going to have an aquaculture, it's going to be offshore, then you would need means to monitor it remotely. So maybe through that, we can have some synergies on how we can monitor effectively locations such as the Kakoskali Cave.
Sounds good.
So before we start session 6, there is one last question, or I guess a set of questions. Despina is asking, what is the reproduction rate of lionfish? And then also asked, what is the mechanism of lionfish spread? the water depth of the drift of eggs or larvae.
Okay, so as I said, we have done, maybe I didn't, we have done a gonadal development analysis. We found that they reproduce throughout the year, perhaps slightly more in the summer period, but I think was not significantly different. So they have the ability to reproduce throughout the year. They, as I said, the females can lay over 2 million eggs per year, and their eggs are transferred by the currents, basically. So the expansion rate, I'm not sure how to express that, but if you can imagine what happened around Cyprus within just 5 or 6 years, and then in the Mediterranean again within 5 or 6, 7 years, then you can see that their expansion rate is pretty impressive.
Do you know at what depth these eggs are laid, and when they are transferred, what depth that would happen, or we don't know that yet?
I don't know what exactly what the answer to that is, but I can tell you that we have samples of really tiny juvenile lionfish from the deep. So it's possible that the eggs laid in shallow areas transferred to the deep, or maybe the eggs are laid in the deep. We don't have enough samples from the deep to know whether adult female lionfish are found. So we could potentially assume that they lay eggs also in the deep, but we know that they can move from shallow to deep areas quite quickly. There is a study from Israel, I think, where they tagged lionfish and followed their movement through. I think the tags were using sound technology, so they could track their movements, and they were moving within a day from 20 meters deep to 60 meters deep. So I think there is a lot of mixing of populations from shallow to deep.
Very good, thank you.
Awesome. Thank you, Luis, for your presentation and for answering all of our questions. We're going to transition now to session 6, which is titled Strategic Goals of the Cyprus Marine Community. So we're adding on actually several additional panelists. So if everyone can introduce themselves, and Dan will be moderating this session.
Just to give a little background, so the session today, I think, is a good opportunity to pick up where we left off yesterday in terms of how to collaborate on a specific task. We already have a lot of overlap, and to optimize our efforts and come up with something better than any of us would be able to do on our own. And that is to do with the buoys. So we heard about STEAM and Marisense and OS Aqua, and all of those projects involve ocean observations, at least over the duration of the project, and some investment in infrastructure in terms of buoys, some sensors. Partners have donated sensors for that project's purposes, and there will be some equipment like mooring hardware and so on. At the same time, we have news from CMMI that they are interested in also supporting that effort. There are buoys available, or through their partners, also expertise and willingness to support and help coordinate. So the idea today is just to kind of investigate those different ideas from a practical standpoint. Like, so what do we have? Where do we want to put it? For what purposes? we know there are many users out there. Some of them are online, hopefully. I know DFMR has expressed interest yesterday and in the past, but also on how we could manage that in the future. And if there's a willingness, then we could, at a later stage, go through some of the details about that. So just to start, then, I think it would be good if the people that we've sort of, I guess you would say, promoted as panelists, so you should be able to see their names now on the screen, if they could just say who they are and what, where they're coming from, and very initial thoughts on how they would like to see a cooperation, or what they would like to contribute or to get assistance with. So maybe we start with, well, Yannis, and then we'll go Herodotus, Zacharias, and
Hello,
then
everyone.
George. Yep.
Yeah, so I talked yesterday about the project Marisense. Also, we have OS Aqua. Both of these projects deal with the maritime area, and especially Marisense is interested in developing intelligent applications for maritime, which includes software and hardware. In order to develop this software, for example, and the hardware that is linked to that, we need a lot of data. So data-driven models need data, and our software, for example, deep learning applications, they need data to verify and also build applications that are customized to that kind of data. So definitely we will be interested in monitoring and collecting that data.
Okay, good. Herodotus, you want to make some comments? I mean, we heard the talk from Steam yesterday, but we didn't get much into the buoys. Do you have some thoughts on the buoys and maybe a little bit about what you do?
Of course. Good morning, everyone. Herodotus here. I'm an assistant professor at the Cyprus University of Technology, and I'm currently the technical coordinator of the STEAM project. Now, we heard about the STEAM project yesterday from Michalis Michailidis. So the overall goal is to essentially improve, the management of sea traffic in the general area of the Eastern Mediterranean, with a special emphasis on the port of Limassol. And there are different actions that are part of the STEAM project. I'm not going to repeat what Michalis said yesterday. One part of it has to do with improving the operations of the port of Limassol. Another big aspect has to do with the environmental sustainability of the area. Now, as part of this latter effort, we've also, acquired some equipment such as the buoys that Dan has already mentioned, some oil detectors. We already had some environmental monitoring stations for collecting various types of data. Now, all of the data, at least for some of the equipment we have now, is being collected, processed, and stored in a platform that we've also developed here at the university. So at this point, we're definitely looking forward to explore more synergies with a lot of other organizations, try and find ways to both share the equipment that we have, that we could make available for other projects, and vice versa, if they have some equipment and some data that they're willing to share, right? We can have some good collaborations by expanding essentially the pool of equipment and data that everyone has.
Mm-hmm. Yeah, great, okay. Zacharias, would you like to make a statement before we get into the maps and the details?
Yeah, yes. Good morning to everyone. I talked yesterday, so possibly some of you already know. I work for CMMI. I'm the CEO since last December, almost a year there, but in reality, due to the COVID, we actually really started to employing people the last 2-3 months. We are now almost 20. So we are now moving ahead much quickly, much more quickly. From the start at CMMI, we realized the importance of these issues you are discussing. And so one of the centers within CMMI that we decided to establish is called the Cyprus Marine Observation Network, which aims to bring together all this effort in monitoring the sea around Cyprus and beyond, possibly. We are trying to use the money that we are getting from the EU and the government of Cyprus in order to make something that will be consistent and continuous, and it will not be just a short project which finishes and then everything is lost. You know much better than me. I come from a different industry myself, but I've heard a lot of stories from all of you, so I know how it is. So since we are now establishing this institution, which aims to last much longer than the usual EU or RIF projects, we want to establish a data center, a mission control room where we can get all this data. The good thing is that the DFMR, as Dan mentioned, is also very supportive. We even submitted together a proposal for further funding in this direction under the Resilience and Recovery Fund very recently. And we are also meeting with DFMR actually tomorrow, exactly on the specific question where we can now start installing some of the buoys that we have from various partners, and how we will then collect the data and use the data. So we are very much into this, and we are looking forward to work with everybody. We are a public equivalent body. We get public money, so we are aiming to work with everybody in this ecosystem. That's for a start, yeah.
Thank you very much. Quick word from George to introduce himself, because you didn't get a chance to speak yesterday.
Thank you very much. Good morning. I'm George Triadafilidis. I'm a hydrobiologist, and I have worked with Zacharias as a start for Cyprus with in this Blue Career Center, and based on that we initiated another collaboration with Dr. Kyriakidis in this OS Aqua project. I heard with very interesting the presentations and the ideas, and I wanted to say to Mr. Hadjioannou if he is aware of the MEDAC. MEDAC is the Mediterranean Regional Advisory Council for Fisheries. So they have the idea to establish an observatory or something like a center that will monitor the invasive and alien species. I was trying to tell them that we should establish such centers in the two corners, in the Gibraltar Strait and in close to the Suez Canal. And Cyprus is the ideal place to host such a center. I think that we should further lobby in order to realize this idea and bring these activities in Cyprus. And also I have some other ideas for this platform that we could potentially use also eDNA techniques. eDNA is the so-called environmental DNA, which is a complex mixture of genomic DNA from many organisms found in the marine environment. And this DNA comes from different sources like the skin, the scales, the sperm, the eggs, and various other tissues of the animals that these very sensitive techniques can detect. So with this environmental DNA analysis, we can potentially detect the invasive alien species, but we could possibly apply it also for doing stock assessments. The European Commission heavily subsidize all member states to gather data on fishery stock assessments. And this eDNA technique seems to be a quite promising tool for the future in order to have a better understanding of the vast biodiversity in the Mediterranean. For your information, the Mediterranean hosts thousands of species, and I think the fish species are about 1,000, and we only know for 5, 6, 10 of them what is their status, if we know also for them. Sardine, anchovy, hake, and so on. So it is really important that these future activities of, that you're trying to build will embrace also eDNA techniques that could potentially, these will involve sensors, sampling units, and a variety of other technologies in order to realize it. Thank you.
Yeah, very good. So with that, I think we turn over to Rana, who's one of my colleagues as well, who will introduce herself and tell us a little bit about what we've done in terms of the buoys so far in this potential network. This is mostly about the STEAM project, which I presented very briefly yesterday. But Jana, please go ahead and give us a little introduction.
I work at CSCS. I'm an environmental consultant. We have been working for the past 2 years with CUT, Totoceo, and other collaborators for the STEAM project in order to set up a monitoring program for the port of Limassol, which could be extended with the help of Maritime, OS Aqua, and possibly other projects in the CMMI, to have as complete as we could view of the marine area around the coast of Cyprus. Let me share my screen.
So the idea is this is a live map. So we will hopefully get your input here, especially Konstantinos, who we didn't hear from today, but we heard from yesterday. You can hear us, right, Konstantinos? You're online.
Yes, of course. Good morning.
Okay, good. We can barely hear you though.
So as we presented yesterday, we are planning to put 2 buoys in the Limassol area. One is across the marina. This is the marina and this is the port. And the other one is across the Nautical Club in Limassol. We are planning to have on them some sensors. For example, this one would have temperature, salinity, chlorophyll A, dissolved oxygen, and maybe noise, a hydrophone, as discussed yesterday with Konstantinos. And one more buoy is planned for the OS Aqua. Yesterday we talked about the spatial planning for the offshore aquaculture. We are still discussing which areas are a possibility for the OS Aqua, but for one specific area, the project aims to do a more in-depth study of the conditions. One area that is a possibility, and that is still under discussion, of course, is the area by Larnaca, because as we saw from the maps that were shared yesterday by Geomatic, we have this area that does not have any other military or either other activities.
Yeah, and that we were shooting for deeper depths than in the case of STEAM.
And we can add a subtract. We can edit. We can add suggestions from you right now on the map, or either for sensors that you would like to see on either buoys, or locations that you would like to see monitored. Again, through a buoy.
Yeah. So the other two buoys we had discussed so far were the CMMI buoys, and DFMR also has interest in certain locations. Would either of you guys like to propose anything, or you have a wish list, or what areas are you considering, if you have anything in mind at the moment? Does this cover you? I mean, what are your priorities also in terms of sensors?
If I may, Dan, we had a discussion this week with DFMR for another project we are discussing, and we were thinking whether we could have a buoy at Amatunda in front of the Ehsan port in that area, close to the artificial reefs that they have been installed a few years back by DFMR. To get some parameters that we may need for another project that we are discussing with them in relation again to the underwater reefs that they have there.
Let's see if we can get that on the. Yeah, I don't know exactly where that is, to be honest. I have to. Let's see.
We're actually thinking of visiting the area next week. Just.
Oh, right. I see it now. Okay.
So this is Amatunda Beach, and you mentioned in front of?
There is an area which is designated. I don't know, possibly Luis knows better than me because I haven't really been there myself. I understand that there is a marine protected area for an artificial reef that was put there in, I don't know, 7-8 years ago by the DFMR. It was the first artificial reef. And I understand it's in front of the ancient port of Amatunda.
Indeed, yes, it's there. You're right.
Here? Should I just place
it? There, yeah.
Is it about 20 meters depth? I think they were at that phase using 20 meters as a guideline.
I'm not sure, but possibly Dan, they have the actual location and the limits of the area on the DFMR side, so maybe we can look there because I'm not sure.
I'm gonna put a temporary place mark here just to see it on the larger map, and then correct it, and maybe at the end of the workshop I'll send to everyone a view of how it looked like.
Can I just ask something? I'm not sure I understood correctly, but all the buoys that you're planning to install are very close to each other?
Well, in the case
relatively.
in the case of steam, the idea is that the port is here, and then you have the anchorage area, and we need to know what pollution and what's the situation before and after the anchorage area, because the anchorage area is quote unquote problematic area of its own. And that's the reason why the steam buoys are relatively close to each other. But yes, if it was a different monitoring program, you would probably want to space them out so that you can have more coverage.
And then you were talking about two further buoys that will be installed under the CMMI umbrella. And the areas are, apart from Amatunda, do you have any thoughts on where to put them? Because from my understanding, it would have been interesting to put them, as Rana said, spaced out and covering a more wide geographic distribution within the southern coast of Cyprus, of course, and perhaps the east and west as well. From a biological perspective, it would be interesting to record and get data from those areas as well, which are quite different, biologically speaking.
Yeah.
Well, actually, we are meeting with DFMR tomorrow just for this reason, because we were also asking where they would like us to put the two buoys at least that we had, so okay, they suggested Amazunda for the artificial reefs. So we do have another one. So we are waiting to hear from them what they will suggest.
From just another comment, and I pass on to whoever else. I understand that there is logistical reasons also on why to put them close to ports and close to places, areas where you can visit regularly, and also have them more secure, because it's known that vandalisms happen in the sea. But for example, because I mentioned that there are different biological parameters in different areas, and would be interesting to record also the physical-chemical environment or other also parameters. With respect, for example, with invasive species, the southeast, close to Cape Grego area, is the hotspot. We know that most alien invasive species arrive there before they move around to other areas of Cyprus. So it would make sense, for example, with that respect, to have it as a focus area. Just an example.
Yeah, and there's a question, Yorgos Nikolaidis from the University of Cyprus, and this is, Yorgos can introduce himself, but he's working on Lois Aqua as well with this potential buoy. Well, it will be a buoy deployment. Of course, we don't know where. Could be in this yellow square or rectangle, or it could be somewhere else. But he's asking if there's a plan to possibly put the second CMMI buoy in a deeper location in coordination with DFMR, perhaps. Maybe it's too early to ask, but if you have any thoughts, Zacharias or Konstantinos.
But at least the one for Amazunda, I guess it's going to be in shallow. I mean, less than 50. Yeah, if this is the definition. For the other one, we don't know, but of course, it's always the matter of cost with the anchoring, as you know better. So once they tell us where they would like to have it from their side at DFMR, then we need to do our calculations. We had plans for a much bigger buoy. We do have plans for a bigger buoy, which could also go in deeper waters, but have to build it and equip it before we promise anything.
What are the dimensions or approximate size of the buoys in your partner network? Do you have a rough, how big roughly they are? Are they medium, small?
I think they are. I mean, I'm not sure which is the right parameter for a buoy. I'm more familiar with ships, but I think it's about 2 meters diameter.
Okay. So the ones we received yesterday for the STEAM project are a bit smaller than that. So if we did put them in deeper water, we'd have to make sure to use a lighter line so they don't pull them under, or an intermediate float to help reduce the load from the line. But yeah, we had to speak to the experts about that.
Yeah, I think the challenge is for us at this is the mooring line rather than the actual buoy. We have designed with a proper naval architecture calculations a buoy of 6 meters diameter for another project in the past, and we do have the structural and all the drawings. It's just and we even provided for a generator on that one. But yeah, the challenge is always the depth. I mean, as you know, the cost goes very high once you get to big depths.
Yeah.
And do you have an idea of what sensors you would like to put on those buoys?
For the CMMI buoys, we had a consultation. We used as project leaders, let's say, our partners from Smart Bay Ireland, who are quite familiar with this subject. So we prepare a feasibility study for the whole Cyprus Marine Observation Network concept, and we have split the whole concept into phases. So we in order to prepare an initial budget for all these phases, our Irish colleagues, they went through around and talked to all the local stakeholders in Cyprus, so the DFMR, either the Meteorological Service. I think we even have a talk with the Cyprus Institute and the Land Surveys Department. So we try to talk with as many of those involved in order to get their requirements or expectations. And this we are considering in preparing the budget for the initial phase. And I think we have them there done. Maybe if you have read the feasibility study, maybe you remember better.
Yeah, no, it's some of the things that we've already identified. Really, it's nothing really unique or demanding. I mean, there is stuff on the market, so we can definitely find these sensors. We can install them. There's some question about what can be done in real time and not in real time. So we have to discuss that further at some point, because that also costs. And then, of course, if you're going to measure something like a waves or currents, that's a bit more complicated. Definitely it can be done, but we have to decide which of the buoys and if that's real time or not. So it's a lot of things to consider. But yeah, it's we have, I think, a good list of sensors, and I mean, maybe we could go to the next, we have a few minutes left, to the next phase, which is, you know, for this to work, we'll have to all kind of agree, I think formally, on how this will be operated and how it will be funded and how the data will be shared or not, and with all the right mechanisms, so everybody wins and everybody's happy. And I get the feeling that everybody is on they're in the favor of this kind of discussion. We won't be able to do all of that now, of course, but I think maybe the next step is to start meeting and building some kind of an official consortium or something that can say, you know, we are the Cyprus Monitoring Observation Network and we are playing this role and the data are here and so on. Does anybody have any advice or any suggestions on that or on that process, or any mechanism in mind on how we can do that? Or any objection to that, if you'd rather do that on a case-by-case basis, maybe that's more simple. So yeah, okay, that's a good sign. I think nobody's complaining too much, or they're being shy.
And then what I could suggest, I don't talk because I'm not an expert on this field, so I'm waiting for you to say something. But definitely, as CMMI will, once we engage into the Simon implementation, and we are and we have the budget approved and so on, and we start deploying the system, I think we could host also the other colleagues who have views on the specific field and coordinate whatever we are doing, because the idea of Simon is not something that it will only be done by CMMI. We are just trying to create the network where everybody could plug their systems and eventually have something that will be kind of a permanent network monitoring the sea. So either platforms or mobile platforms. So we could lead as CMMI this effort if everybody agrees, because we will have a dedicated center. So it's a good also task for our Simon colleagues to undertake this role as well. If you
well, I think it comes down to the data, and sense that if we have to arrange the data so that if there's something that needs to be protected, we have a mechanism to do that. But personally, I hope that these data are of public benefit, so they should be shared through a center. Now, CUT has a platform, CMMI maybe have a platform. There are other platforms around Europe. If we can make them at least talk together, like machine to machine, so we can see what data are available, even if it's not physically stored in the one place. But if we can agree that we share some information about the data, and if not the raw data, maybe a graph or something, I think that's a huge step forward, especially considering all the history we've been through, that we haven't been able to really get that single point where people can see what's going on and what can we get and who do we talk to and so on. So, I mean, for me, that would be a big achievement, just to say, look, we have a single place where we can go and see where there are or have been buoys or whatever it is. Even if we don't get the raw data, at least we know what's there and who's behind it. But that's my kind of personal opinion.
Dan, maybe tomorrow after we meet the DFMR, we can also discuss this possibility, whether we could undertake some kind of mapping of what is available and both with regards to assets and people. I also have a question from Elias. And of course, the buoys are intended to be expandable. I guess the volume of, at least of our buoys, are sufficient to be able to undertake future sensors if needed. And for me, building new buoys is not such a big issue. We have done it in the past, as some of you know. So we don't see that as a challenge. Mooring is the main challenge rather than the buoys. We can even design them and build them ourselves. That's not an issue. So we can easily expand them and add additional sensors. I understand, for example, that in Amathunda they want sensors that can measure the currents there.
Yeah. So there's a picture of the steam buoy, and so it's hard to see. I couldn't get a good picture, but there's a room in the bottom for a current meter that would be not obstructed by the attachment point. And there's some room for some things here. So I think technically we have a lot of options. So I think a matter of coordinating is going to take time, and hopefully we can all be in touch with each other after this event. We will maybe have to start an email list or some kind of a way to keep informed. We don't want to wait another year for this meeting. So we'll keep you all posted. Is there any other feedback about this session? Because I think we have to go ahead, Luis.
Dan, sorry, is there a list somewhere of the different sensors that you plan on putting on these buoys, so that we can provide feedback? I mean, for example, I have no idea what kind of, or whether if you do plan to put any sensors or collecting samples for biological parameters. But for example, what Mr. Triandafilidis suggested about eDNA would be very interesting if we could collect water samples for these kind of purposes.
Yeah, that's a good point. I don't think we have a centralized list. I think each project at the moment has a list of sensors, and maybe each stakeholder has a list of sensors. So that, or parameters, you might say. So I think that maybe that's a good step to do right away. And maybe in parallel with the organization, the coordination, we have a section on sensors. That I guess it's the beginning of sort of a pool that could involve sensors and platforms, and this could be expanded later. A list of what's available, who is the contact person, some links maybe about the specifications. That would be really good. Good. I'll make a note of that. Thanks. But for terms of communication, yeah, go ahead.
Oh, sorry. I wanted to make some comments about the data sharing that you mentioned a little earlier. Actually, I wanted to share an experience we had recently with marine traffic. People are not familiar with that. That's a ship tracking platform. It uses AIS data to track ships. So what they do with regards to data, if some organization has data that they're willing to share, they can go ahead and do that. And then at the university, we had installed an AIS receiver, so we had a live feed that we could share with marine traffic. And we did that, and by sharing the data, we got access to the data that they have as well. So based on that model, if you think about it, they get news sources all the time. They grow their network, they have bigger coverage, and then everyone benefits from it because now everyone who's sharing data also gets access to everyone else's data. Now, of course, with AIS, I mean, it's a very simplistic model. I'm not saying that we can go with that, but it's definitely something that's worth considering, especially with basic monitoring data.
Yeah, I agree, and it may be also a way to make things more interoperable. So if you share the data, you have to meet a certain standard about what is in that data and how it's formatted. Otherwise, it's not really easy to be used, right? And so we don't want to just provide people with raw, uncalibrated data, an Excel file with no labels. It won't be useful, even if you can say you're sharing it, but it's not really useful. So if people share, they should also have some minimum amount of information, or at least maybe a format or something they can use. And especially if you could drop that into a visualization tool without any formatting additional, then that would be another benefit. And then you could say, well, then we're a member of this group because we provide data and then we get data back. I think that's a really good point.
Yeah, I mean, figuring out, correct formats and make things compatible, to me, that's probably the easy step. Well, could, but as long as people are willing to share, then there's going to be a lot of mutual benefits that would come out of that sharing. At least that's our belief.
Great. Very good. Well, we have to find a way to communicate, but we will. I don't know if you have any ideas before we close on how to keep in touch with each other. We're small, but we're busy, a small group, and the attendees are also, welcome to raise their hands. But any thoughts on communication, on how to maintain? Do we start an email list or something? I'm afraid to send emails to mass groups of people anymore with all the GDPR. So it's better if we have a voluntary sign up somehow.
Well, from our side, we are okay, done. I mean, talking for CMMI, yeah. If we need to give our consent in writing, again, we don't have an issue if it comes to GDPR. And definitely we can assign a colleague in CMMI to be the contact point for this project. Yeah.
Good. All right. Well, we'll think about this one. If you have any ideas, please contact us. But I think it's good to stay in touch. I think that's the bottom line. And there's so many things happened in the last year that this workshop has been good to get a really, full picture of all the activities. I learned a lot, and I thought I knew what was going on. So I hope everybody also benefited from the workshop. I think we should close here. If you have a last comment, please raise your hand. But I'm going to close just by saying thank you to, first of all, the organizers, CMMI, Maritime, CUT, and all the speakers as well. It was a very interesting 2 days. I know it wasn't the most desirable way to do this. In person is always good, but we actually had equal or higher attendance than we had last year. So maybe there's something to this. Yeah, and thank you to the moderators as well, and all the attendees for taking the time. I know it's not fun sometimes to sit in Zoom for too many hours, but I hope you enjoyed it. Please stay in touch, be in contact with us. Feel free to ask questions about the projects, and stay tuned for more announcements, whether it's LinkedIn or the websites. We'll find a way to keep in touch over the next few months. And so happy holidays, enjoy the quarantine, and take care of yourselves.